If you want to remember what you were doing exactly 1 year ago, you probably just scroll through your phone's camera roll to check the timestamps and the photos. But the Earth records its own history in a much colder way. Looking at this photograph of Antarctica, it's easy to see only a stark white landscape, a place that looks like a giant blank page. Reaching this place is a grueling journey. You have to cross 9 time zones, navigate through half a dozen checkpoints, and board a research vessel like this one to sail across 3 different oceans. Because this continent is so isolated and has never sustained a human population, it remains pristine. That lack of interference makes Antarctica the ultimate undisturbed diary of our planet's physical past. If we flip this diary back 650 million years, the map looks completely different. This diagram shows a massive southern supercontinent called Gondwana, which sat right where Antarctica is today. Humans hadn't arrived yet. Back then, the global climate was much warmer, and the land was covered in a huge variety of tropical plants and animals. Eventually, this giant landmass began to separate. You can see South America drifting away to the north, while the section that would become India started its own journey across the ocean. When India finally crashed into Asia, the force of the collision buckled the Earth's crust. That massive geological event is what pushed up the Himalayan mountain peaks you see in this photo. Looking at Antarctica's ancient history reveals that our modern countries aren't just isolated islands. They are the scattered pieces of a much larger interconnected puzzle. To understand our role in this story, imagine Earth's history as a 24-hour clock. Human civilization has only been around for 12,000 years, just a few tiny seconds at the very end. In those few seconds, we've built massive cities and expanded our population across every continent. As this image shows, that rapid growth has often left the air thick with smog. This happens because we burn massive amounts of fossil fuels, like coal and oil. This releases carbon dioxide, which creates a thick, invisible blanket around the world. This blanket traps heat, which is steadily raising the average global temperature and straining the resources all species need to survive. Since humans have only been around for a few geological seconds, how do we know exactly how much the atmosphere has changed over time? The answer is hidden in the ice. This researcher is examining an ice core, a sample drilled from deep underground that contains 500,000-year-old carbon records trapped in its frozen layers. But to see how the planet handles carbon today, we look to the water. These are phytoplankton, microscopic plants drifting through the Southern Ocean. These single-celled plants use the sun's energy to absorb carbon from the environment. This process nourishes the entire ocean's food chain and keeps the global carbon cycle in balance. Scientists have found that as the ozone layer thins, these tiny plants struggle to survive and process that carbon. If these microscopic organisms fail, the seals, the whales, and the birds will soon follow. The health of our entire planetary system depends on these tiny biological foundations staying healthy. Standing on the deck of a ship is one experience, but the reality of the environment truly hits when you climb down the gangplank to walk directly on the frozen ocean. You're standing on a meter of white ice, knowing that directly beneath your boots is 180 meters of living saltwater. All around you, the landscape is full of life. These crab-eater seals use the floating ice to sun themselves, just like a dog might find a patch of shade under a tree. Seeing this fragile world is why the Students on Ice program brings teenagers to the South Pole. It gives the next generation of leaders a chance to see the stakes of climate change before they start making policy. It's one thing to hear about melting ice caps in a classroom, but it's another to stand here and watch a massive glacier crashing into the sea. It makes the threat of a warming world feel immediate and real. What happens to us if Antarctica loses its ice and returns to the warm, tropical climate it had millions of years ago? We have to wonder if humans could survive that kind of shift, or if we would join the dinosaurs and the woolly mammoths as species that couldn't adapt. 1,000,000 years is enough time for nature to move continents and build mountains. Our own history is just a tiny fraction of that timeline. We are only a few seconds on the geological clock, but we are the first species with the power to choose what gets written on the next page of Earth's diary.